All right, y'all. Today we're going to be talking about right triangle trigonometry. We started by our very first day, if you remember, all the way to the beginning of Unit 3A. We talked about SOHCAHTOA, sine, cosine, tangent. Sine, of course, is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is equal to opposite over adjacent. But we're going to expand on that today, and we're going to add in their reciprocal trig cousins. So sine's reciprocal is cosecant. Cosine's reciprocal is secant, and tan's reciprocal is cotangent. What I mean by that reciprocal, if you remember what fraction reciprocal means, to switch the numerator and denominator of the fraction or flip the fraction. So it's the same idea. So if sine of theta is equal to opposite over hypotenuse, its reciprocal cosecant of theta is hypotenuse over opposite. Cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent, and tan is opposite over adjacent, so cotangent is adjacent over opposite. So we've already been analyzing and finding sine, cosine, and tan. We're going to add in cosecant, secant, and cotangent today. So we can actually evaluate all 6 of our different trig functions as we look at right triangles. So let's look at the right triangle down below. We have our angle theta that we're going to be analyzing. We have a hypotenuse of 4, and we have one leg of 2. And before I can start finding all my other sides, I want to try and find out what is this unknown side. And let's go ahead and call that unknown side A. So I don't know what A is equal to. Now I have a right triangle, and I have 2 sides of those right triangles. So if you remember from geometry, with right triangles, we can find a third side of a right triangle by doing Pythagorean theorem. So A squared plus B squared is equal to C squared. As we've already stated, A is what we don't have. B is my other leg, so 2, and C is going to be 4. So this is going to become A squared plus our B squared, which is 2. And that's equal to our C squared. So 4. Solving that out, we would get that A squared plus 4 is equal to 16. Minusing 4, we get that A squared is equal to 12. And then from there, I want to still solve out for A. So I square root both sides. So we get A on the left side, because that's going to cancel out. On the right side, yes, the square root of 12. One way I could solve it is by plugging it into the calculator, but I don't have a calculator. Let's assume that. So instead, I can look if I can reduce it. So I can simplify the square root of 12 into the square root of 3 times 4, because 3 times 4 is equal to 12. Now, I can't take a square root of 3. That's a prime number, but I can take a square root of 4. So this becomes the simplified square root of A is equal to 2 square roots of 3, because that is what the square root of 4 is. 3 stays underneath. So this is what we call simplifying or reducing a radical without a calculator. Anytime we can split a number into perfect squares, we can to reduce that square root. If we can't, if it's a prime number under the square root, then we just leave it a prime number like we left 3. So A is equal to 2 root 3. So now that we know that, we have all 3 sides, we can start filling in our trig ratios. And filling in your trig ratios is as simple as just taking what they are. So sine is opposite over hypotenuse, and filling out that fraction. I'm not going to be solving for theta. I'm just setting up the fraction. So sine is equal to opposite over hypotenuse. In this case, my opposite side is 2. My hypotenuse is 4. So sine is equal to 2 over 4. And then, of course, if I can, I always want to look to reduce. So 2/4 does reduce down to just 1/2. And that would be my final answer. And that's all there is to it. Now, some of them, of course, if I have radicals, I might have to do a little bit more work. But it's really as simple as that. So let's keep going. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse is going to be our 2 root 3 on top, and then hypotenuse 4 on the bottom. 2 root 3 over 4, the root 3 is not going to reduce, but 2 fourths still reduces down to 1/2. So this does become 1 root 3, and then over 2. Last but not least, tan of theta, I want to do opposite over adjacent. So opposite side is 2, adjacent side is 2 root 3. So tan of theta is equal to 2 over 2 root 3. Now this one, I now have that radical on the bottom. I am going to go ahead and simplify it real quick first. So 2 over 2 root 3 is equal to 1 over root 3. 1 over root 3. I have that radical in the bottom. I got to get it out. So I'm going to multiply both the top and the bottom by root 3. So times root 3 and times root 3. And the reason I can do this is because root 3 over root 3 is really just 1. So I'm not actually changing the value of the number. I'm just multiplying by 1. So this becomes on top 1 times root 3 is equal to root 3. And root 3 times root 3, the square roots cancel out. I'm left with just the number on the inside, so 3. Okay, so now that we've done our standard trig, we want to move over to our reciprocal trig. So we have cosecant of theta, we have secant theta, and we have cotangent of theta. Now there's nothing we're going to do different for them. It's the same exact piece. We're going to take whatever the sides they say they are, and I'm just going to set up the fraction, reduce or rationalize if I need to. So first off is cosecant of theta. If sine of theta is opposite over hypotenuse, then cosecant of theta is hypotenuse over opposite. So once again, off of my angle, my hypotenuse is 4. So 4 over, in this case, my opposite side, which is 2. So I can see very clearly that from sine of theta to cosecant of theta, their reciprocal is 2 over 4 becomes 4 over 2. And then, of course, 4 over 2 does reduce down to just 2. So that's all I'm doing as I'm moving from my original trig to my reciprocal trig, is I'm just taking that reciprocal, I'm switching the top and the bottom in the fraction. So cosine theta is adjacent over hypotenuse, which makes secant theta hypotenuse over adjacent. So instead, this one is now 4 over 2 root 3. Now, just like before, I'm going to reduce this one down. So this will become 2 over square root of 3. 2 over square root of 3. Of course, I still have that root 3 in the bottom, so now I need to rationalize. So times by root 3 and root 3. And that's going to give me a new simplified 2 times root 3 is 2 root 3. And root 3 times root 3 is 3. So 2 root 3 over 3 is my new simplified secant ratio. And last but not least, we have cotangent of theta. If tangent of theta is opposite over adjacent, cotangent of theta is adjacent over opposite. Adjacent, that's 2 root 3. And my opposite is just 2. And in this case, 2 root 3 over 2 is going to reduce down to just root 3, because the 2 and the 2 will cancel out. So that's really all we're doing with our right triangle trig, is we're setting up our triangle, solving for whatever side we don't know. In this case, we didn't know side A. So setting up our triangle, solving for our unknown side, and then whatever trig ratios, a question's not always going to ask you for all 6. They might only ask you for 1 or 2 of them. Whatever trig ratio you're being asked for, you just give that fraction, that ratio, that opposite over hypotenuse, adjacent over hypotenuse, hypotenuse over opposite, whatever it is, you just set up that ratio using those sides on our triangle. So let's flip over to our second page and let's talk about some different scenarios. So the triangle we looked at, this is a triangle that was in quadrant 1. Note that all of its sides are positive, nice and simple and easy to remember. But our triangles on our coordinate plane are not always in quadrant 1. They can be quadrant 1, 2, 3, or 4. So to help us remember how to draw them in each quadrant, we use the bow tie method. Okay, so the bow tie method, see, it makes a bow tie with the 4 different triangles. Our angle theta is always that angle that's off the origin, and then our right triangle is always, that right angle is always made against the x-axis. So note some things we don't want to do. We don't want to draw a triangle like that, where the right angle is on the origin. We don't want to draw a triangle where our angle theta is the angle off the origin. We're always going to draw it like one of these 4. So once we determine what quadrant we're supposed to be in, we're going to set up as one of those 4. Okay. So let's look at number 2. So given that sine of theta is equal to 3 over 5, we want to find the other 5 trig ratios of theta. So I'm going to go ahead and add that one in. I already know what sine is. It's equal to 3/5. Nice and simple. Okay. But now I'm going to go ahead and draw my triangle. So the only piece of information they gave me is that sine is positive. They didn't tell me anything else. If they only give you one piece of information or they don't give you enough information to assume that my triangle is outside of quadrant 1, then we're just going to assume it's in quadrant 1. So we're going to use our bow tie. We're going to draw our triangle correctly. And then I'm going to use sine. Sine is opposite over hypotenuse. So opposite of my angle is here for 3, and then my hypotenuse would be 5. And before I can do my ratios, I have to solve for my one unknown side, which is my adjacent side right here. Now, if you know your Pythagorean triples, you might already know that that last side is 4 because it's a 3, 4, 5 triangle. If you don't know your Pythagorean triples, then we can still use Pythagorean theorem to try and solve for that unknown side. So in this case, I don't know 4, so I'm going to do 3 is my B, 5 is my C, so a squared plus 3 squared is equal to 5 squared. So a squared plus 9 is equal to 25 minus 9. We get a squared is equal to 16, square root and square root, and we get a is equal to 4. So if we know our Pythagorean triples, sometimes our sides turn out nice like that. If we don't, it's okay. We can always fall back on the Pythagorean theorem. So now that I know my sides, I can fill out all of my ratios nice and simple. So cosine is adjacent over hypotenuse, so that would be 4 over 5. Tangent is opposite over adjacent, so that's going to be 3 over 4. And then, yes, you can memorize your ratios. Or if you just know the reciprocal relationship, so sine becomes cosecant, cosine becomes secant, tan becomes cotangent, then you can just take the reciprocals of all the fractions you've already found. And that makes it really simple. So you can either just take the reciprocal, or you can remember cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Not a fun acronym, cow doesn't really have the same ring to it as SOHCAHTOA, but still fairly simple to remember. Like I said, if you know sine and cosine and tangent, and you know cosecant, secant, and cotangent are the reciprocals, then you can just take the reciprocal of each fraction, and it's fairly simple. Okay, so let's talk about 3. So 3, if tan of beta is just another letter for an angle, that's okay, we can use that, is equal to 4, and sine of beta is less than 0, then we want to find the other 5 trig ratios of 4. Well, I'm going to go ahead and add one piece of information. We know tan of beta is 4, so let's make our life easier. Okay, and then using the information, we're going to try and determine which quadrant the triangle is in. So if tan of beta is equal to 4, so the first piece of information they've given us is that tan is positive. Okay, and going off of what we know of all students take calculus, tan is only positive in quadrant 1, our all quadrant, and quadrant 3, our tangent is positive quadrant. Then sine of beta is less than 0, so that means sine is negative, and sine is negative in quadrant 3 and quadrant 4, because that's when y is negative. So my overlap was in quadrant 3, so I'm going to go ahead and draw a quadrant 3 triangle. Okay, then from there, if tan of beta is equal to 4, 4 is the same as 4 over 1, so that means my opposite side is 4, and my adjacent side is 1. But because I'm in quadrant 3, I actually need to note that both of these are negative, because negative 4 over negative 1 would still equal 4, but it accounts for our triangle being in quadrant 3. So now the only thing I still need to do with my triangle is I need to solve for that one side I don't know, so I can use Pythagorean theorem. So in this case, I have A and B and C. The hypotenuse is what I don't know. So negative 1 squared plus negative 4 squared is equal to C squared. So 1 plus 16 is equal to C squared. So 17 is equal to C squared. Take my square root of both sides, and I get root 17 is equal to C. So my hypotenuse is square root of 17. And one thing you might note, even though I'm in quadrant 3, the hypotenuse is still positive. The hypotenuse of your triangle should always be positive. Only the x and the y directions are going to change and become negative. Okay. So with that being said, I now have all 3 sides. I'm going to let y'all practice. Okay, so go ahead and pause me and see if you can fill in the other 5 trig ratios using what you know about these sides. All right, also hopefully you can check your answers now. You can see they should hopefully look like mine. The big thing, sine and cosine, we got negative 4 over root 17 and negative 1 over root 17. You need to make sure you rationalize both those. So multiply by root 17 over root 17. Okay. Cotangent, we get negative 1 over negative 4, which is still 1/4. And then cosecant and secant, root 17 over negative 4, root 17 over negative 1. We don't need to do anything with those. Square root on top is fine. I just can't have a square root at the bottom. So those are all good to go. Okay, so number 4, pause me now if you want to go ahead and try and set up this triangle without my help, but I'm going to still help you out with a triangle. So pause now. Okay, so if you want to go ahead and still do the triangle with me, we're going to read the question. So suppose theta is an angle whose terminal side passes through the point negative 24, 7. Find the 6 trig ratios of theta. So they haven't given us any of our trig ratio, but they've actually given us a pretty helpful piece of information. The point that it goes through negative 24, 7. So negative 24, 7, negative x, positive y. So that's actually a point over here in quadrant 2. And if that point is the point of my angle, the point of the side of my triangle, then my triangle is actually going to be drawn here in quadrant 2. And remember, I still draw it with that angle theta here on the origin, the right angle there against the x-axis. Nice and simple. Now, the other piece of information with that being negative 24, 7 is they've given me 2 sides of this triangle, negative 24 because that's the x distance, and 7 because that's the y distance. So then the last thing I can do is I can solve for my hypotenuse. This actually is another Pythagorean triple. It's a 7, 24, 25 triangle. But of course, if you don't know how to do that, we can still do Pythagorean theorem. So negative 24 squared plus 7 squared is equal to c squared. So we get 576 plus 49 is equal to c squared, which gives us 625 is equal to c squared, square root, and we get c is equal to 25. So we can always go back to Pythagorean theorem, even if you don't know your Pythagorean triples. And I do want to make a note, I didn't talk about it on number 3 back here, but root 17, we didn't reduce that like number 1 when we did earlier when we had the square root of 12. And that's because 17 is prime. I can't split that and into any square roots. I can reduce out of the root. So I just leave it as the square root of 17. So that can happen. You don't always have to be able to simplify the square root. Okay. But now on number 4, you have all the information you have. You can go ahead and fill out the ratios. So go ahead and fill those out. You can pause me now and then check your work here in a second. All right, so go ahead and check your sine, cosine, tangent, your cosecant, secant, cotangent. Hopefully you've gotten the same answers as me. Make sure you do watch out for the negative, that negative 24, but 7 and 25 are positive, so you get your negatives and positives in the right spot. And then last but not least, y'all, we're going to kind of pivot. We've done our bow tie method. Hopefully you feel pretty comfortable. We're going to pivot to something we did back in the beginning where we solved cosine, secant, tangent, and cotangent, and that sort of stuff. But we're going to actually solve them using the calculator. We're going to look at B first. We'll skip B. We'll go to C first. I know, a little bit weird, but we have the tan of 173 degrees. So if I gave you a calculator, could you solve this? And with the calculator, we're going to type in tan. So I use my tan button. And then our angle was 173, and it is degrees. But I want you to note, see that little degree symbol? That tells us we're in degrees. So just like we talked about with SOHCAHTOA, I need to go to my mode real quick and check. Right now I'm in radians. I'm going to go and change it to degree mode. So tan of 173. It's in degrees, so it should do it for me. I get negative 0.1227, so negative 0.123 is going to be my actual point. So the only thing to keep in mind when you're doing these is you need to know what mode it's in. In this case, this one was in degree mode. And from that, I got my answer of negative 0.123. I still want to be reducing it down to 3 decimal places. So with each of these, you just want to check what mode is it in. Is it a degree measure or is it a radian measure? So you want to be in the correct mode. And then for these reciprocals, so if you note, we're going to go to B. B is secant of 7 pi over 8. So the secant of 7 pi over 8, that one is definitely in radians. So I'm going to end up changing my mode on my calculator when I get to it. But before I get there, I don't have a secant button on my calculator. If you go back to our calculator, you'll note we have a sine, a cosine, a tangent button. We have sine -1, cosine -1, tan -1. Those are not the secant, cosecant, and cotangent buttons. That's inverse trig. Inverse is different than a reciprocal. So we don't actually have a reciprocal trig button. But if you remember back from our identities that we talked on that very first page, our reciprocals, they have a relationship. So like sine of theta is equal to 1 over cosecant. Cosine is equal to 1 over secant, which means secant is equal to 1 over cosine. So going back here, the secant of 7 pi over 8 is equal to 1 over the cosine of 7 pi over 8. And then that's what I can actually go and plug into my calculator. So in my calculator, I'll come over here, alpha y equals, so I get my nice fraction, 1 over cosine of 7 pi over 8, 7 second pi over 8. And before I hit enter, I'm in degree mode, so I need to go to my mode, go down to radians, second quit, hit enter, and then I should get my correct answer of negative 1.082. So big thing you need to make sure you're in the correct mode. And then beyond just being in the correct mode, if it is a reciprocal trig, then you need to change it to its original by doing the 1 over, and that way you can type it into the calculator. So go ahead and practice A, D, E, and F. Pause me now, and then you can check your work here in a second. All right, so going over these, cosine of 5.4, that's in radians. So plugging it in, we get 0.635. Cotangent of negative 23. Even though it looks like a degree measure, there's no degree sign. So that means it is still in radians. So change that over to 1 over tan of negative 23 in radian mode, and we get negative 0.630. E, we have cosecant of 16 pi over 9 degrees. So even though there's a pi in there, there's a degree symbol, which means this has to be in degrees. So I convert it over to sine, and then I make sure my calculator is in degree mode, and I get 10.275. And then last but not least, for F, sine of 5 pi over 3, that is in degree mode. Sorry, did I say degrees? This should definitely be in radians. All right, so fix it up. Right answer, negative 0.866, but wrong mode. It should have been in radians mode, which I did use radians. I just wrote the wrong one on the paper. But hopefully this makes sense. If you're not, please feel free to come to tutorials, ask questions with any of these. This is the 6.3 right triangle trig notes, so make sure you do the 6.3 right triangle trig homework to help practice, and then you have those review questions as well. All right, y'all, that's all I got for you today.